Hello and welcome to York Observatory's special event, TeleTube. This exciting Mars landing event is an extension of our regular Wednesday night show, which provides an online astronomy and astrophysics program every Wednesday night at 7:30 p.m. So just so you know, this special event on Thursday is for today only because, of course, the fascinating Perseverance rover landing. Just in general, for any questions or comments you might have about our past shows, or if you have suggestions for future topics, you can always email us at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle @York Observatory, and on Facebook at Alan I. Carswell OBS. For this show, we will be taking live questions in the YouTube chat, so feel free to join in, ask questions, and say hello to each other. Just to get us started here today, a little bit of a welcome to the Perseverance landing. I hope I'm pronouncing that right. But I will be one of your hosts today. Hello, I'm Dr. Elena Hyde, and I'm actually live at the Alan I. Carswell Observatory in the hope that it will stop snowing so that I can open the 1-meter telescope for you all. Now, of course, I am here this evening with several fabulous crew members. I have Amin, Gagan, June, Noah, Shannon, Matt, and Jesse has hopped in as well. We might even get Paul Delaney or maybe even Julie Tome later if we're very, very lucky. So we are broadcasting, as I say, live from the Alan I. Carswell Observatory at York University, located in Toronto, Ontario, Canada, where unfortunately it is currently snowing, but if it stops, I will run up and open up the telescope for everyone. So tonight we have all kinds of great Mars content for you to celebrate this special event for Mars Perseverance rover landing. So a big thank you to everybody for joining us, and a big fingers crossed for hopefully the third successful mission to reach Mars this year. So I thought what we'd do is I'd go ahead and start with a little riddle. Just to get everybody in chat awake. So riddle me this, YouTube chat folks. Can you answer the following? I'm red, but not a stoplight. I'm named after a Roman god, but I'm not Apollo. I have a Mount Olympus, but I'm not Greece. I have polar ice caps, but I'm not the Arctic Circle. I'm a planet, but I'm not Jupiter. What am I? So if you know the answer to this riddle, please go ahead and type it into chat. And while you're there, say hello to everybody else who's joined us today. So without spoiling the answer, let's go ahead and get started here. As we're going, I do want to just go ahead and mention that the moon and Mars are in fact up right now. This is one of the reasons why, if it stops snowing, I look forward to, of course, turning on the telescope. Now, what is up is a general question for all kinds of folks, but astronomers tend to very specifically mean astronomical objects. We want to give you a little update just in case you have clear skies and are looking up. We can see the moon and Mars. So you can see the moon and Mars right now if you have good eyesight and clear non-snowy skies. So right now in Toronto, it is in theory daylight, and the moon and Mars are visible with the naked eye. If you squint a little bit, you can just make out the bright red shining light of Mars coming through. Now we can see Mars later tonight, so if it clears, once the sun goes down, of course, your light will be much less. It'll be much easier to make out the bright red shining Mars and the moon. At 8 p.m. it will be particularly good in the Ontario area. So if you are around, as they like to say in Australia, don't forget to look uppity. And you'll be able to see lots of other things tonight as well. So you can take a peek at Rigel and Sirius and Betelgeuse. So there's all kinds of stuff up in the sky. And indeed, we can see we could, in theory, see Mars right now. So while this lander is in the process of approaching the atmosphere of Mars, putting itself in a bit of a dangerous situation, we can actually see the planet. Now, we wouldn't have a remote chance to actually see the lander go down from here. Our telescope is not that good. But we will be following along with NASA's broadcast as soon as live images start coming up. So, just as a little schedule for today, what are we going to do today? Well, as you know, this is the landing has actually begun. We're approaching the Martian atmosphere, or I should say, Perseverance is approaching the Martian atmosphere. And we'll be sort of following this general schedule. So in about an hour, the cruise stage separation is going to begin. And we'll have, of course, a few minutes of initial stages, and finally the last 7 minutes, or the 7 minutes of terror, as we'll talk about later on during this broadcast. So as we get towards the end, we'll find out if the lander has successfully touched down. So just a little bit to get us started here as well, since we are at the LNI Carswell Observatory, I just want to give a shout out to our LNI Carswell Mars connection. So just in case you haven't heard, our observatory is called LNI Carswell because Professor Emeritus LNI Carswell actually helped us to buy the 1 meter telescope with a $500,000 donation in 2017. So the 1 meter telescope is up there right now waiting for the snow to stop, and it has been installed. And the Mars connection actually comes in because LNI Carswell was a co-investigator of the Mad Dog LiDAR instrument accepted by NASA for inclusion in the 2003 Mars lander mission, which was also a really fascinating mission. And although the mission got aborted, the LiDAR instrument development work continued, and he actually ended up getting his name engraved on the Phoenix lander, so the NASA 2007 Phoenix lander. So LNI Carswell, the name is actually on Mars, on the spacecraft, the Phoenix spacecraft. So in a small way, our observatory is actually kind of on the red planet as well. So we have a little bit of a connection with Mars. It's probably not a coincidence that we have been running so many Mars events. It helps that Mars is very, very interesting, of course. So let's just get ourselves started here. We'll sort of start our general part 2 here. And I just want to give a quick shout out to our observatory crew member, Obada, who created this beautiful landing poster. Unfortunately, he was not able to join us tonight to give, or I should say today, to give a little recap of it. But he created this poster to advertise the landing event and, of course, the current, hopefully successful Mars event here. So to get us started, it always helps to talk a little bit about what came before, and of course, what types of other missions are around. So this is the third of 3 missions arriving at Mars. So I'm going to hand over now to our observatory member, Matt, to tell us a little bit more about some of these other missions and, of course, what's already at Mars safely. Take it away, Matt.
Well, thank you. The first Arab space mission, the UAE Hope probe, reached Mars orbit on Tuesday, the 9th of February, making it the first of the 3 spacecraft to arrive at the red planet this month. The United Arab Emirates, China, and the United States all launched projects to Mars last July from the Tanegashima Space Center in Japan, taking advantage of a period where the Earth and Mars are at their closest approach. Hope, known as Al-Amal in Arabic, will orbit the planet for at least 1 Martian year, or 687 days, while the Tianwen-1 from China and the Mars 2020 Perseverance rover from the US will both land on Mars' surface. Hope is now running an initial ellipse around Mars that comes as close as 1,000 kilometers from the planet and goes out to almost 50,000 kilometers. Over the course of the next few weeks, this will be trimmed to a 55-hour, 22,000 by 43,000 kilometers orbit, that is inclined to the equator by about 25 degrees. It is from this high perch that Hope plans to carry out some novel research. One of the main objectives of this mission is to study the leakage into space of neutral atoms of hydrogen and oxygen from Mars' atmosphere, remnants from Mars' once abundant water. This will add to our understanding of precisely how a previously warm and wet planet became the cold, dusty, desiccated world it is today. And will also help us understand climate dynamics and the global weather map through characterizing the lower atmosphere of Mars. The final objective is to explain how the weather changes the escape of hydrogen and oxygen by looking at the behavior of the lower atmosphere conditions with the upper atmosphere. The Emirates Mars mission is tasked to provide the first ever complete picture of the Martian atmosphere. Three state-of-the-art scientific instruments have been designed to study the different aspects of the Martian atmosphere. The first one is the Emirates Mars Infrared Spectrometer, or EMIRS, which is, as its name suggests, dedicated to map and study the infrared spectrum coming from this atmosphere. Then the Emirates Exploration Imager, which is in charge of imaging the atmosphere and the planet in high resolution pictures. And finally, the Emirates Mars Ultraviolet Spectrometer. But as I mentioned earlier, this is not the only fascinating mission that is going to study the red planet. China has its own too. Tianwen, which in Chinese means question in the heavens, is a double mission consisting of an orbiter and a rover. It is China's first Mars mission, and it successfully entered orbit on February 10th of this year. For 2 months, the space probe will study the target site from a reconnaissance orbit. Then in May or June 2021, the landing would begin with the release of the capsule. It would make an atmospheric re-entry followed by a descent phase under parachute, after which the lander would use its propulsion to land smoothly on Mars. It would then deploy the rover designed to explore the surface for 90 Martian days. The orbiter serves as a telecommunications relay during the rover's primary mission, then would place itself in an orbit more conducive to observations while retaining its role of relay. From a scientific point of view, the mission must meet 4 main objectives. The first is to study the morphology and geological structure of Mars, as well as its evolution and its causes. To do this, the probe will analyze the topography of the planet with precise data from characteristic regions such as the dry bed of rivers, the reliefs of volcanoes, wind erosion, glaciers, and at the poles, etc. The 2 cameras present on the orbiter are dedicated to this objective. And the second objective is to study the composition and types of rocks, as well as mineral and elements present on the surface of Mars. This is to analyze the carbonate or weathering minerals present in ancient lakes, rivers, and other landscapes resulting from the past presence of water on the planet, such as hematites, lamellars, silicates, sulfate hydrates, or even perchlorate minerals in order to establish the link with the watery past of Mars. The spectrometers on both the orbiter and the rover, as well as the multispectral camera, are dedicated to this object. The third objective is to study the ionosphere, the climate, the seasons, and more generally, the atmosphere of Mars, both in its near space environment and on its surface. This is the role of the 2 particle detectors present on the orbiter, as well as the rover's weather station. And lastly, the mission will study the internal structure of Mars, its magnetic field, the history of its geological evolution, and the internal distribution of its mass and its gravitational field. The magnetometers, as well as the radars present on the orbiter and the rover, are dedicated to this objective.
All right, thank you very much. That's a great summary, and we always love to hear about what happened before and what kind of interesting missions are already there. Of course, exploring the atmosphere is a really wonderful process altogether. Now, just to get us started here, let's go ahead and talk a little bit about the main mission, Perseverance. Its predecessor, its capability, and what it can do. So we have Perseverance. The Perseverance rover is actually about the size of a small car. So on Earth, it would weigh around a ton. Obviously on Mars, it's going to weigh 38% or so of a ton because Mars has a lower gravity. Now, after landing, the rover is going to search for signs of ancient life, gather samples to be returned to Earth eventually. And it's also going to use all kinds of cool hardware and have a lot of new features as well, including, of course, the Ingenuity helicopter, which I believe will be talked about a little bit more later. So there's a bunch of different science and measurement goals that Perseverance has. In particular, it has 4 main goals, which were looking for habitability, seeking biosignatures, caching, depending on how you say it, those samples. So actually collecting rock and core samples, storing them on Mars, and then we'll worry about how to get them back later, but also preparing for humans. So if you're interested in humans on Mars, you want to test oxygen production from the Martian atmosphere, this mission will help you with that. And of course, a test flight of the Ingenuity rover. So we are just talking about Perseverance, and we have a special guest appearance. Julie Tome, are you here?
I am.
Wonderful. Hey, Julie, it is great to see you. So this is just a little call out. Everybody say hello to Julie Tome. This is a sort of a surprise guest appearance. Julie, why don't you tell everybody a little bit about what you do and why you're interested in Mars here?
All right. Well, I am, I guess the best way to describe myself work-wise is I am a science communicator. I've worked at a number of museums and science centers. And one of my favorite things to do at work is use the planetarium. So we have a lovely planetarium, which actually happens to be the projection system happens to be sitting next to me today because I've been doing some presentations. But I love bringing people into the dome and immersing them in space and other things. My connection is, of course, that I studied astronomy at York, and I worked at the observatory for the 5 years that I was at York. So I'm always glad to pop back in, say hi, and
of course,
touch base.
We will try to open up the telescope if the snowstorm stops. As you can see, I am here getting ready for that. Now we are joined, so this is a very interactive broadcast. We're having people hop in all the time. We have Julie Tome. We also have Paul Delaney. Paul, you just joined in.
I did indeed. Glad to be with you, albeit briefly.
Hi, Paul.
Hi there, Julie. Yes, I remember your times in the dome and the amount of time we spent observing together. That was a few years back now, of course.
A little while ago.
In a galaxy far, far away? No, not really.
No. Same galaxy, but a while ago.
Absolutely. Everybody should be getting excited and sort of tingly at the fingertips, given the fact that we're just over an hour away from landing.
Indeed, we've been just doing a little bit of introduction here, getting everybody started. So we talked about Tianwen, Hope, and we were just starting to talk about the fun things that Perseverance might be able to do if it survives. So Julie, I don't know how long you have, but you and Paul, feel free to chime in with whatever fun Mars things you have. Paul, you've got to hop away relatively soon here, right?
Yeah, about 3:10. As a big media day, as you can well imagine, everybody wants to understand what's happening today. So yes, I will be popping away about 3:10. But I'll try and come back just prior to the landing. That's my plan. I'd like to be with you all when it actually happens.
Yes, we will do a big recap for everybody who wants to turn their cameras on and cheer or cry at the end. So feel free to stick around for that. In the meantime, do you have any thoughts you'd like to share on the landing?
Well, the one thing that always strikes me as such a significant change, and let me just wax eloquently, hopefully, for a moment or so. I remember when Viking went down onto the surface of Mars back in July of 1976. That was the very first time that NASA managed to land a spacecraft on the surface. No internet at that point in time, and it was in Australia. The landing was set for around about 10 p.m. on one night during the week, and I was studying away merrily at university. I remember thinking, gosh, there's got to be a better way to find out whether or not this thing is going to go down at 10 o'clock or not. And of course, there wasn't. You had to wait for a radio broadcast confirmation or a television broadcast confirmation of some description. And I knew it went down at 10 o'clock, and I was listening to the news and waiting. And it got to 10:13. And I was getting positively desperate to know whether or not the spacecraft had survived. And then the news came on, and I actually recorded it on a cassette recorder. I have this sort of little snippet of history in my archives, and it went down successfully. You had no idea what was going on. The vehicle separated in orbit, the lander from the orbiter, because it was a twin mission in that regard, but you knew nothing about what was happening. By contrast, today, we are going to have a blow-by-blow, moment-by-moment expose of what's actually happening. I don't know whether that's better or worse for your nerves, but it certainly is a much more intense and exciting experience. So, yeah, I remember curiosity back in August of 2012. I'm hoping for the same level of success today for Perseverance, but it's such a change from 1976. It really is.
Indeed, it is. It is, as you say, interesting times. But at least, if we have to be isolated, we can do it all together here and watch a lander while we're going.
Correct. Absolutely correct. And let's face it, everybody is really showing terrific interest. I mean, it's a landing on Mars. We can all band together and become excited over this, the beginning of a mission that will probably be between 2 and 10 years in length. If you look at the way Curiosity, Spirit, and Opportunity have fared on the red planet. So yeah, this afternoon is just a big plus, a huge ride for us all, particularly obviously for the science community, but everybody loves astronomy. And as Elena will tell you, everybody loves Mars too. So yeah, this is a great afternoon for NASA and the rest of the planet.
Absolutely. Thanks so much, Paul, for joining in. I know you've got limited time, so
yep.
If you have to escape at some point, we will see you when we see you.
Yes.
Now, Julie, I know you've also got a little bit of limited time. Are there any fun Mars things you're particularly looking forward to?
It's the sample return aspect of this one that's really interesting for me. I was watching when OSIRIS-REx did its touchdown. And so that gave me a bit of an idea of what we'll be seeing today as far as how it's different from having everyone in the same room and seeing everyone on the video because of the current situation. But also that the sample return is just like, yeah, we're going to decide to sample here, and then we're just going to leave the sample there. And some other mission later is going to come and pick it up. It seems... well, it's definitely a different way of doing a sample return than what has been done in past years. And it seems like taking a big chance.
I think the short answer is we just don't have the technology yet to actually do it. And there's a concern that if we keep going down to the surface as we are doing, we're going to quietly contaminate the samples. So, get the pristine samples in place now. But yeah, you're right, Julie. We've got to wait potentially another 8 years before ESA and NASA get their acts together and feel they have the confidence to bring them back.
Oh, I totally like, I get the reasoning behind it. But I also like, so many space missions are delayed for various reasons. Like, it just seems like, yes, at least 10 years, and then we'll have these samples. But it's definitely a cool thing to try.
Indeed. And of course, we're all looking forward to it. So I'm just going to, as we're chatting here, put up a live map of the landing site, Jezero Crater, just so we have this too. This is where we're trying to go today. And we also have one more person who's been hopping in and out of chat. Jesse Rogerson, do you want us to come in and say hi?
Hey everybody, yeah, I'm here. You're Julie, Paul, Elena. It's so good to see you all. I just wanted to jump in on that conversation. The act of waiting for the samples. So you have the samples that are sitting there on the surface in their capsules or in their whatever, however they're getting them ready, and then they're just going to sit there. And the point, I understand the point where you're trying to keep them pristine. But it's an unplanned mission. It makes you wonder how long it's going to be before you get them. But we'll have those, which will be an interesting time capsule, because then we'll be able to compare them, because eventually we're going to do more and more missions to the surface of Mars. And eventually we'll be able to do the sample return. We'll be able to pick these up. Maybe this will be a good thing to be doing, where we do packing up samples ongoing for every mission, and then you get samples in a timeline of limited pristineness. I guess pristineness dropping down through time. It's an interesting thing. It's a really interesting part of the mission, and it's definitely I want to say flavor of the week kind of idea, where you have there's Bennu and there's Ryugu, and then there's Mars. It's like we need these samples on Earth. We need our laboratories on Earth to do the best science possible. Either that, or we need to send an entire laboratory to Mars, which of course would be the goal of a permanent scientific outpost. So there's
I'm volunteering. I'm volunteering.
You're volunteering. Oh,
my hands up. My hands up.
I'll go with you, Paul.
Yeah, exactly. Wouldn't it be an exciting rush? I mean, we've read about moon missions, Mars missions, exoplanetary voyages, and so on and so forth. It sounds like science fiction, but I tell you what, we're getting closer and closer to it being science fact. And that to me is very, very exciting.
Indeed, I think it's very exciting for all of us. It's we're starting to learn more and more, and of course, we're also testing our first flight capabilities with this mission.
Ingenuity will take wing, if I can use that term, probably about a month or so afterwards. I don't think Ingenuity is on the docket for the first few weeks, but it certainly will be in short order. And I think that'll be one of the next most exciting aspects of this mission.
Can I say one thing about Ingenuity, which just hits home a little bit for me, is so this is the first powered flight, or at least hopefully the first powered flight on another planet. I'm not going to get into the details of Ingenuity, because there's a great little presentation that's going to come up about that soon. But what I really love is I come from the museum world. I worked at the Canada Aviation and Space Museum. Some of you may know the Smithsonian's Air and Space Museum. These are places where we have created a line between here is Air Museum and here is Space Museum. We are the Air and Space, or the Aviation and Space Museum. But the interesting thing about Ingenuity is that it is going to blend the two. It will now be both space and aviation at the same time. And the interesting science and engineering that goes into developing powered flight on another planet, with a different atmosphere, with a different specific density, with a different, the list goes on and on for what's required to create lift. And now we're blending it with the engineering that's required to do space science. And it's just a really interesting intersection. It's just like how biology and space ended up intersecting with each other in the last 20 or 30 years or so with astrobiology. It's just a really cool overlap of science.
Agreed. And if we are successful here, and I think there's every reason to believe that we will be, imagine what the possibilities would be for sending similar types of craft to either Titan, the fascinating moon around Saturn, indeed over to Venus, bit of a hothouse, but if you can have a vehicle that is able to keep itself airborne, and maybe that will be a balloon rather than a drone, but the possibilities, if we can master this technology for further exploration in atmosphered world, if I can use that term in our solar system, sky's the limit. Very, very exciting engineering possibilities that Ingenuity is ushering in.
Imagine the engineering that would have to go into something that would not disintegrate on Venus.
Yeah, that would not be easy. I agree with you wholeheartedly, Julie. But the idea even of a helicopter working on Mars, I mean, it's 1% the Earth's atmosphere. That's really quite an engineering feat by itself. So I'd like to believe that my engineering colleagues, if they can sort it out on Mars, maybe they'll sort it out on Venus too.
And the higher you are up in the Venus atmosphere, like you don't need to go to the surface to do flight, right?
That's right. Exactly. Yeah. Which is why a balloon might be the more practical mechanism.
Absolutely. Yeah.
And as was mentioned in chat as well, a few people are talking about one extra aspect of Perseverance that we haven't actually covered yet, despite talking about the rover and its components. There will actually be a microphone to capture the sounds of Mars on Perseverance, and the landing sounds as well, I hear. So provided that data is returned back, we might even get some early sound results, obviously with an 11-minute delay.
Absolutely. I mean, when we think about the differing options that are flying with this vehicle, to be able to listen, to be able to get a bird's eye view, it just gives added dimension to the entire mission.
Absolutely.
I got my planetarium wheels spinning. I'm like, oh, wow, we get to add real sound to planetarium shows?
Yeah, absolutely, you could.
Yeah, absolutely. I think that is something that we will all be looking forward to, putting in some real sound for these videos and science outreach, of course. In the meantime, we do have some other sounds from ourselves and some of our crew here. I was just going to wrap up a little bit extra about Perseverance. It will have sort of the copy of what happened with Curiosity, the Curiosity rover, which of course has been successfully landed on Mars. And it will have a few extra little things as well. So the difference with Perseverance is, of course, greatly improved sensors and scientific instruments that will be more fine-tuned for detecting ancient microbial life. And I'm not sure if we talked about that before, but really finding out if there was ancient microbial life of the sort that is thought to perhaps have been in the area of the Jezero crater. And that was, this is an interactive map from ESA, so all credit goes to them. They have put up this interactive map of Jezero crater if anybody wants to play with it. But you can see that it is actually an ancient sort of water area. Some folks think that there used to be a bit of a lake here. It's obviously dried up now, but in these types of regions on Earth, you would be able to find microbial life that had been left over from in a river or a lake. So it is a very, very interesting spot. And I'm just zooming in a little bit because this is, I believe this is new data that has been processed, but this is real imaging of the Mars surface. The orange circle is what they're aiming for here inside Jezero crater. And as you get closer and closer, you can see that near the crater, the soil is not as even as you might expect. So there are some sort of sedimentary layers and water features in here. So this is a fun tool to play with. We might come back to this later. So one more thing I'm just going to give a little call out is, of course, to Ingenuity. So Ingenuity is coming down with the rover, and Ingenuity is actually in a little bit of a strange place. It is strapped to the belly of the rover for its journey to Mars. It's a little bit of a technology demonstration. And this helicopter, it's a flight, but a helicopter flight has special blades that are designed to work in the Martian atmosphere. As was mentioned before, this is the first powered flight on the red planet, and as far as I'm aware, the first true flight outside of Earth, not counting, of course, bouncing around on comets and things like that. So this new robot is going to be accompanying Perseverance. And this is the Ingenuity helicopter. So this is some images of what they think it might look like. Of course, all things going successful shortly. And this has never been done before. So a successful flight would provide not just amazing images, but also scientific data and the ability to really accurately help the rover navigate. So it'll be able to do terrain mapping and all kinds of great stuff. It only weighs about 1.8 kilograms. So most analogies that I've seen are it's actually sort of like a drone, but a drone that will work on Mars with extremely high powered blades. So because Mars has a very thin atmosphere, it's very, very hard for things to fly. There's not the atmospheric pressure that we have here on Earth. So this really is an ingenious design. So I suppose that's where it got its name. I'm not sure if this was one that was voted on by school kids or not, but it is very, very fun. So, it will fly for about 90 seconds, and it's got a small battery life, and then it needs to go back to Perseverance. It's no small feat, and if you compare it, 90 seconds is actually quite good. One of the first flights by the Wright brothers was about 12 seconds. So if they get the full 90, it will be the first example of flight on another planet, and a pretty major accomplishment. Alrighty, so now let me just see here. We have one more quick little call out. Actually, I had almost forgotten. I did want to give a call out to another one of our amazing posters created by our crew member, Shannon. I believe this is yours. Do you have your intro for your poster?
Yes, I do. Just give me 1 second to find it. Okay, so hello everyone. This is the poster that I made. It's pretty simple, and I made on Google Slides actually, which you're a little bit surprised because Google Slides is horizontal and landscape. So the first thing that I did is actually I made the slide vertical by changing the dimensions. So at the bottom of the poster, you can see our observatory logo and our event logo, which was made by one of our crew members, Noah. The image in the background is of Mars. The image was actually taken at our observatory by our 40-centimeter telescope. The image of Mars, as you can see, has a shadow type of effect, and this effect was actually done on Google Slides as well. The poster is very much simplistic, and I thought that writing would stand out more if the background was more darker and simple. So this poster didn't take very long to make, but I enjoyed every second of making it.
Wonderful, thanks so much. And that just to give everyone a little insight, all of our crew has worked very hard on these presentations, and including making all of the various posters you might have seen going around on social media and all that good stuff. And just in case you're curious, the 40-centimeter image that Shannon used, we also had these earlier images in our welcome. This was actually from the 1-meter telescope when we were at opposition, watching, of course, the launch of all of these programs last year, around about 6 months ago. So we can get quite good images of Mars through the 1-meter telescope here on campus when there's not a snowstorm. So look forward to that at some point in the future, hopefully. Now, the next one up we have, we're going to actually skip forward a little bit, and we're going to talk about Noah's section, I think. And let me see if I can get that loaded in for here. Noah, do you want to go ahead and talk a little bit more about the science experiments?
Absolutely. Thank you, Professor Hyde. All right, so this day is so exciting, and I, for one, can't wait to see what Perseverance and Ingenuity will bring discovery-wise. There will be many discoveries, as numerous technologies and experiments will be conducted in the near future. Honestly, too many to list. So here I'll explain a select few of these from the Perseverance rover. To begin, let's start with some of what Perseverance is trying to determine, or the questions it'll be analyzing. First of all, what are the environments on Mars, namely the climate and geology? What were these environments previously? And finally, the big question we've all been asking, is there life on Mars? Has microbial life ever existed there? To answer these questions, Perseverance will be looking for biosignatures in its landing site, the Jezero crater. It'll do this by, for example, looking for organic molecules with a UV laser, known as scanning habitable environments with Raman and luminescence for organics and molecules, or SHERLOC. The cameras on board, by imaging light across the electromagnetic spectrum, will document Mars and its history. And samples that it collects will hopefully later be returned to Earth to provide more information on Martian life and evolution. Something fun about SHERLOC is that its calibration target is inscribed with the words 221B Baker, and its camera is known as Watson, the wide-angle topographic sensor for operations and engineering. A lot of what Perseverance will complete is also to gain insight into considerations necessary for future crewed missions to Mars. This is evident through SHERLOC, which, on top of all its analysis technology, carries 5 spacesuit materials to determine their lifespans under intense radiation. On board lies orthofabric, which is part of the outer layers of spacesuits. There's also Vectrin and Teflon from spacesuit gloves. There's also dust-resistant Teflon and polycarbonate, commonly used for helmets and their visors. The Mars Entry, Descent, and Landing Instrumentation 2, or MEDLEY 2, on the heat shield and back shell will similarly prepare for upcoming missions by analyzing entry through Mars's atmosphere with sensors, such that future landings can be perfected for safety, especially for crewed missions. There is also the Mars Environmental Dynamics Analyzer, MEDA, which will measure wind, cloud, temperature, humidity, radiation, and dust, including the effects of dust on technology for future exploration, such as potentially limited quantities of light reaching the surface during storms. Once aware of these implications, they can be accounted for prior to crewed missions. Now, I'm going to explain a little bit more about Perseverance itself. Did you know that it has a 2-meter-long robotic arm with 5 joints that consists of a camera, UV and X-ray spectrometers, a rock drill, and other materials? Curiosity has similar features. However, Perseverance's are larger and more precise. For example, to enable the splitting, sampling, and storing of rock cores and regolith as part of the sample caching system. In total, Perseverance carries 19 cameras, more than previous missions, each for a different purpose of engineering, science, entry, descent, and landing, to get a comprehensive view of all aspects of the mission. On board also lie 2 microphones, as I saw some of you mentioned in the chat. One to capture audio as Perseverance lands, including what NASA calls, and I quote, ambient Mars noise, which I'm really excited to hear soon. And the other to record wind and the sound of lasers hitting Mars's surface for rock property analysis. Perseverance also has 6 wheels, which are specially designed with what are known as grousers, or deep treads for traction on the Martian surface, more wear and tear resistant than those of the other rovers before it. Not only that, but 3 computers exist upon the Perseverance rover. 1 main computer and 1 backup, plus 1 specifically for image analysis and autonomous navigation. Perseverance is also sustainable, being run by electricity from the multi-mission radioisotope thermoelectric generator. And that's a mouthful, so I'll be calling it MMRTG. Here, plutonium-238 radioactively decays, releasing energy, which will be converted into electricity to not only charge 2 lithium-ion batteries, but also to maintain heat around the rover and technology when it's on Mars. Because Mars has an average temperature of negative 63 degrees Celsius and can even lower to negative 140 degrees Celsius. It's important to mention that the MMRTG is extremely effective in eliminating the dependence of the rover on solar activity for energy. So, in previous Mars missions, mementos from Earth were present. ranging from gold records on Voyager 1 and 2, to metal from the Twin Towers being carried aboard Spirit and Opportunity, to names of the public, which began in 1997 with Pathfinder. Perseverance is no exception, and it also has a large variety of fun and inspiring features worth mentioning. Just as previous missions did, Perseverance has silicon chips with names inscribed on them. Unlike in the past, however, Perseverance carries with it a groundbreaking 3 chips with 10,932,295 names from people around the world, as well as 155 essays from the Name the Rover contest. Beside the chips, NASA actually included a diagram of Earth and Mars aligned with the sun in the center, the words "Explore as One" written in Morse code as the rays of light emanating outwards. I actually sent my name to Mars, so I can say that I'm quote-unquote landing today. Feel free to comment in the chat if you sent your name to Mars on Perseverance too. Next, calibration targets on Perseverance are spiced up with interesting add-ons. For example, Mastcam Z, which consists of 2 cameras on the so-called head of Perseverance, has a sundial surrounded by both color and grayscale patches to ensure ideal images are produced. Interspersed throughout the swatches, though, is a drawing of life and development on Earth, beginning with planetary orbits and DNA before depicting humanity and rocketry, essentially our search for life and our goal of exploration and discovery. At the bottom lies the phrase, 2 worlds, 1 beginning. And although unfortunately we can't see it here on the slide, it also asks, are we alone? Stating that, and I quote, "We came here to look for signs of life and to collect samples of Mars to study on Earth. To those who follow, we wish a safe journey and the joy of discovery." At the same time, SuperCam, which measures vapor to determine the composition of rocks and surfaces after aiming lasers at said rocks and surfaces, actually also has a bit of Martian meteorite, one that was interestingly enough collected when it ventured past the International Space Station. And finally, humanity's fight during COVID-19 is depicted on a commemorative plaque as a time which truly emphasizes our perseverance. Fitting name for a rover that launched in 2020, right? This plaque features Earth atop the rod of Asclepius, the iconic medical symbol, to commemorate healthcare workers and their fight to, essentially, save the world. Now I'll be passing it back to Professor Hyde.
Thank you very much. That is a wonderful, wonderful summary. Of course, getting us all very, very excited about what Perseverance can do. And it's probably a good call out as well to everybody watching live. We are keeping an eye on, of course, the updates from NASA. So we haven't gotten any new signals back from the telescope. Or I should say from the rover, and we haven't been able to open our telescope, but we are in the final readiness check. So the rover is currently in the final readiness check area. So what I'm going to do now is just give a little call out here to our general schedule of events. So we are almost, so we've just got another 20 minutes starting now until cruise stage separation. Right now, we are still in the final readiness check from NASA, which means that, of course, they're getting ready for that entry, descent, and landing, the EDL that is part of the 7 minutes of terror, where many things could go wrong. So we're getting closer and closer as we approach our landing, and the spacecraft is getting closer and closer to Mars. So the mission team, the communications stations, and the spacecraft are all working together at this moment, leading up to this cruise stage separation in about 20 minutes from now, presuming that all of our clocks are correctly synced up. So it is very exciting times. And it's, as they say, only 20 minutes until we know if cruise stage separation was a success. That is one of the first stages that we have to hurdle past on our way to landing, of course, at Jezero Crater on Mars. And I think just as a little call out here, this is probably a good time as well to give a shout out to where on Mars we are going. And that is, of course, we have a bunch of different ways that we can try to orient ourselves on Mars. As I said, in the next 20 minutes, we'll be looking at cruise stage separation. And then in about 30 minutes, atmospheric entry will start. So if you are watching this on YouTube, I think there's about a 30-second delay. So subtract about 30 seconds from that. We might be a little bit ahead of schedule, but we will keep an eye on the live broadcast and update these numbers for you as our information comes in. So just as a little shout out here, I thought I would go ahead and point really quickly to where on Mars we are going. So you saw earlier the Jezero crater zoom in interactive from ESA. Where is Jezero crater on Mars? And this is actually a little trivia. Can anyone in chat tell me where on Jezero crater, or sorry, where is Jezero crater on Mars? So is it in the south? Is it in the north? And keep in mind, some of the images you will see have been flipped around. So if you get an image from a telescope, it might be mirrored. North could be south and south could be north. So if you were to try to find Jezero crater and the Perseverance landing site, where on Mars would you all look? This is a question open for chat, so anybody who wants to take a guess can. And in the meantime, what I'll do is I'll sort of refer back to this giant map of Mars here. And what we'll look at is, this Jezero crater is located, so here's your first clue, in the so-called Isidis Planitia region. Isidis Planitia. And I've got a prop, so bear with me here for a second. Borrowed from the 1 meter telescope warm room. Since I cannot bring you all up to the warm room now, I'm doing the next best thing, and I'm bringing Mars to you. So if this was Mars, and we'll call this the right way up. So this is Mars North. We might try to find ourselves first Isidis Planitia. And if I turn my Mars around, I can see that Isidis Planitia is right next to this dark albedo region of Syrtis Major Planum. So this region is actually very, very easy to find on a map of Mars. And this is one of the main regions that we would look for if we were able to go to Mars with our 1 meter telescope and have a peek. Because even at a great distance, the pattern of the albedo region will show up. And so what I'm going to do now is, because it is a blizzard and I cannot open the telescope in a blizzard, I will actually show you what Mars looks like right now on the Mars profiler. So if we could point our telescope to Mars from Earth, this is the part of Mars that we would be able to see. And so I'm just putting this in. This is the Sky and Telescope Mars profiler. Very, very handy if you're ever planning on doing some Mars viewing and you want to know what features you're looking at. So Syrtis Major is one of the largest features on Mars, and it's very, very easy to find. It's a big black region, and you can see that actually the pattern of this region is flipped from my globe here. So this is a mirrored image, and they've put the Syrtis Major here, and then Hellas Basin, which is in the south, is up on top, because they've actually shown it as it would look flipped through a telescope view. And if we were looking straight at Mars right now and there was no blizzard in Toronto, we would be centered on this red circle, which means that our landing site, so this is Isidis Planitia, now that I'm in Isidis Planitia, all we have to do is go inside this area and zoom in and zoom in and zoom in. And so right now, if you can imagine it, the rover is hurtling towards the Martian atmosphere. And once it gets there, it will begin, of course, the EDL and the 7 minutes of terror to actually land safely on the surface. But for now, if you were to try to orient yourselves, you would all be able to find our landing site. So all of humanity's, I suppose. If you were to first look for Syrtis Major, then look towards Isidis Planitia. and that would allow you to zoom in. So you actually only have to find one of the largest features on the entire planet to be able to see where we're landing. All right, so let me just go ahead and ping up Julie. Do you have any favorite Mars locations that you'd like to shout out while we've got the globe up here?
Well, I mean, it's kind of obvious, but I do like Olympus Mons.
Olympus Mons. So can we find it on here? I must be able
I would hope so.
Where is Olympus Mons in relation to Syrtis Major?
That I don't know.
It is...
But if you find Valles Marineris, it's nearby.
Oh, here it is. Okay. So as you may know, with a lot of the maps you see for Mars, we have, of course, flattened a round planet. So you do get a bit of a projection effect. Now this Mars profiler, it's only showing us the side of Mars that's currently facing Earth. This will change. So if you watch Mars over the course of several hours or several nights, you can actually see the different parts of its surface as different faces of Mars are close to Earth. So this is a fun exercise. I hope everybody has a little bit of fun with it. So for now, we found Syrtis Major, we found Isidis Planitia, and if we go around all the way across, I can find Ophir Chasma, which was the name of one of my previous cats, Valles Marineris along the other side, and then of course the Tharsis Mons, which has Acrasis Mons and Pavus Mons and Olympus Mons and all of the Tharsis ridge really. So that's on the other side of the planet. So that is not on the side that we're facing now. So we are going to land in an area that is north on the physical Mars. It's not to be confused with what you might see through a telescope sometimes, but it's basically just north of the equator in what's called the eastern hemisphere of Mars. So they do kind of have different hemispheres depending on which side is which. It is obviously all dry, so there's no oceans to delineate it, but these albedo patterns are what we use to navigate our way around here. So this flat plane that we see in Isidis Planitia is actually located inside a giant 750-mile wide basin. And this is why we were talking about water earlier when we zoomed into it. Because if I imagine I'm getting closer and closer and closer to Mars, I'll move my profiler out of the way here. And as we get closer and closer in, we start to see more and more detail. And so this inset here is actually the same image as the European Space Agency's interactive Jezero Crater Explorer. And if we go out, hopefully that updates. There we go. What we can see is this kind of a liquidy water area. So this flat plane was thought to have been created by a comet or an asteroid impacting the surface of Mars. And of course, maybe later on a smaller meteorite hit and created the Jezero crater. And there's a lot of evidence in this area. So here's Isidis Planitia, this area, I should say, that there was water here. There's a lot of possible deltas and what looks like residual water areas. So we think that a river once flowed in to the Jezero crater, and it dried up after some time, and for a while there might have even been a lake at the bottom. So that's why we're talking about, as we go zooming in here to this yellow or orangey circle of the landing site, we can see that as you get closer and closer, there seems to be some signs of water going into that crater. And if that's true, maybe there used to be life in that old water. So the sediments, the clays, the carbonates are exactly the kinds of places that we'd expect to find life if we could look for it in Earth types of dried up riverbeds. So maybe Perseverance will be lucky and we'll find some there. All right. Does any of our other crew want to give a shout out to their favorite Mars surfaces, as long as I've got the globe out here and we are waiting for our confirmation from NASA?
Sure, I'd be happy to share.
Go ahead, Noah.
Yeah, so I'm not exactly sure where it is on the planet, but I personally really like Medusae fossae, the Medusa trenches. They're basically just trenches and hills between volcanoes on Mars, and I just find them really interesting.
Oh, the fossae regions are really, really fun. You'll have to give me a little bit more than near hills, though, if we're going to find it on the map.
Warren
find
Gallagher in
that.
the chat says it's 18 North 77.
18 North 77.
There we go.
Thank you very much, June. Do you have a favorite region on Mars?
Gale Crater I like that one.
Gale Crater is a very good choice. Excellent work. And, you know, very, very fun location. I think my current favorite is probably Nili Fosse. It's a chaotic terrain and a very fun area that has a lot of different features in it. Of course, Jezero Crater might become everyone's favorite soon if we successfully make this landing.
I have to agree. I think it will probably be my favorite.
All right, I'm just going to put this back for a second. Does anyone else have a favorite region on Mars they would like to call out? I see we've still got Paul Delaney here with us, possibly. Paul, would you like to give a shout out to your favorite Mars spot? Maybe not. How about Gagan?
Sure, yeah. I really love Hellas Basin because, you know, it's so deep. I think you can fit all of Mount Everest inside it, and the peak of Everest still won't reach the rim of the basin of the impact crater, which is really awesome.
Absolutely. And of course, Hellas Basin is one of the only places on Mars that has occasionally Earth-like temperatures and pressures in its atmosphere. It still doesn't have an Earth-like atmosphere, but it can seasonally approach a pressure and temperature that is not too dissimilar to the top of Mount Everest, which makes it a very appealing location for a potential Mars house. So thank you very much for mentioning it. Shannon, you're up next.
Yeah, I think my favorite have to be like the North and South poles of Mars, just because of the ice on it is so beautiful. Like there's just so many layers of dust and water, which is ice. The ice caps on the North and South poles of Mars are beautiful. So those are definitely my favorite.
Absolutely. And of course, it was just last year we were all talking about the lakes underneath the polar caps as well. Mars really does just have so much going on for it. And with these types of missions, we're always looking to learn more and discover more as well. And on that note, we do have a little bit of fun exploration and a little bit of history for some different types of space exploration. So actually, I think this is a great time. Amin, if you would like to go ahead and do a little bit of space history. Are you ready to go?
Yes.
Excellent. So let's do a bit of history of space exploration while we wait for the latest update from NASA.
Okay, thank you, Professor. So the first object created by humans to enter space, according to NASA, was an American rocket called the RTV-G4 Bumper, which is a combination of two earlier rockets, one German and one American, that themselves came quite close. It was launched in 1949 and reached an altitude of 393 kilometers. The first spacecraft that was successfully launched into space that orbited the Earth was the Soviet Sputnik 1, and it was launched on October 4, 1957. Sputnik 1, by the way, translates simply to Satellite 1 in English. It weighed 83 kilograms and orbited at a 577 kilometer height on average. On April 12, in 1961, the famous Russian cosmonaut Yuri Gagarin became the first person to reach space in the Vostok 1 mission. Another Soviet mission, Luna 2, was the first artificial object to reach the moon in 1959. Luna 9 was the first to reach the moon without crashing, and Luna 10 was the first craft to actually orbit the moon. The American Apollo 11 spacecraft was the first crewed landing on the moon, and it did so on July 20, 1969. 5 other spacecraft went on to do the same. Since then, various spacecraft have been sent to other planets, moons, asteroids, etc. in the solar system, and a few have been sent beyond the solar system. More recently, space stations have also been launched and will form a part of many possible Moon to Mars exploration plans. So now I want to differentiate landers and orbiters, and I'm going to start with landers. A lander is a spacecraft which approaches a celestial body and actually makes contact with the surface without crashing. This is called a soft landing, as opposed to a hard landing, where the craft hits the surface with too much force and damage is caused. Some spacecraft are actually designed to have a hard landing. Early landers even used balloons to cushion their fall and bounce to a safe location. If there's an atmosphere on the target object, the lander must be able to go through the atmosphere. So a parachute helps, or sometimes they have small rockets that are fired downwards that can help to reduce the terminal velocity enough to make the soft landing. Sensors may be used to measure orientation and adjust accordingly to accomplish controlled descent. The lander will then use its landing gear to rest on the hard surface of the object in question. The first landers sent out by humans went to the moon. Other landers have since been sent to Venus, Mars, and some moons in the solar system, as well as comets and asteroids. Today we are going to follow the next one to land on Mars. In contrast with the lander, an orbiter does not actually reach the surface of the object it's investigating. Instead, as you would guess from the name, it comes into orbit with it. This is also distinguished from a flyby, where the craft does not come into orbit. An orbit is a trajectory which neither falls into the celestial object nor escapes it. Orbiters are constantly falling downward, but the direction of movement is also changing enough to compensate, resulting in usually elliptical-shaped orbit. Orbiters are used to gather scientific data from high above instead of from the surface. Depending on what the scientists are looking for, they will select the type of craft to use. Some spacecraft will fulfill multiple roles, such as the Cassini-Huygens mission, which did flybys of Venus and Jupiter and included the Cassini probe that studied Saturn from orbit, as well as the Huygens lander that landed on Saturn's largest moon, Titan. Mars, being close to Earth with an easy-to-explore surface, has an especially high number of orbiters. The Soviets and NASA sent 8 orbiters there in the 20th century. Other countries have since joined the list, including now China and the United Arab Emirates. I will now discuss missions to planets in the solar system, starting with the closest to the Sun and going outwards. Mercury is the first planet, and it is the least explored of the terrestrial planets. This is partly due to the difficulty in exploring it, and also due to the lack of interest. The Mariner 10 and Messenger missions have been the only ones to come close to Mercury. Bepi Colombo is the only currently active mission, having launched in 2018. There is a proposed mission called Mercury P from the Russian Space Agency. Research topics include the core of Mercury, its surface tectonics, and its magnetic field. Venus, in comparison, has had many more missions, a total of 42 as of now to be exact. 38 of those came before the year 2000 from the United States and the Soviet Union. The Soviet Venera program, which launched 16 probes, was the first to have a probe launched to another planet. The first successful probe that went to Venus, however, was the American Mariner 2 craft. It found out that Venus has no magnetic field. In 1966, Venera 3 crashed onto the surface of Venus, and in 1967, Venera 4 was able to return data measured from Venus's atmosphere. Orbiters and flybys have also been conducted, with 3 missions currently active. Next, Mars is the most explored planet in the solar system, with 49 missions and counting. Mariner craft were also involved here, with Mariner 4 conducting the first flyby of Mars, and Mariner 9 being the first space probe to orbit another planet. In recent times, several rovers have also been sent, but the Perseverance mission will have the first ever helicopter.
All right, and we're just going to take a quick little break here to celebrate the stage separation confirmation. This is true. We have it from NASA. It has separated successfully. So this is stage separation confirmation. We are now 9 minutes to entry, folks. 9 minutes to entry. So this means that the stages have separated, and we're getting even closer to entering the Martian atmosphere. That we have. This is the NASA live feed now confirming it. They are doing exactly what we would expect. The mission control here has just said we have, of course, stage separation, and atmospheric entry countdown is at 8 minutes. So far, so good. Our rover is still with us. How fun is that? So we have about 8 minutes now until we get into the atmosphere. Paul, you want to give a quick shout out?
Just like you, I've got one ear on our broadcast, one ear on NASA, and every finger and toe crossed that I can imagine. So yeah, this is where it really does get exciting. And of course, there's nothing we can do at this point in time. Everything has been pre-programmed. All of the different scenarios have been discussed and fed into the flight control systems. Because of the speed of light, there is absolutely no real-time communication backwards and forwards to the probe. Fingers crossed that all of the literally years worth of preparation for just this moment pay off.
Indeed, and it is, of course, noting as well the tremendous speed at which this object is coming towards the red planet. We are hypersonic, 5 times faster than the speed of sound, and it has to then enter the atmosphere and slow down safely somehow with parachute deployment, and of course the famous, as we keep saying, the 7 minutes of terror, the EGL, entry, descent, and landing. And we're just getting into the atmosphere. So what you saw there was we're still above Mars. The spacecraft is currently transmitting. So we're seeing from NASA, the spacecraft is transmitting normally. So this is a very good sign of, like I said, everyone's got all their fingers and toes crossed, of course. And atmospheric entry counting down here, just over 6 minutes now as we have been chatting.
It's a great example of physics in action when you think about it. 15,000 kilometers an hour, give or take, at the upper end of the atmosphere. And now we're going to exchange a lot of that energy, that kinetic energy, for heat. The vehicle is going to encounter the atmosphere. The atmosphere gets thicker as it descends towards the surface. That, of course, heats up the heat shield. And so we're exchanging speed for energy in the form of heat. The spacecraft will slow down as the atmosphere gets thicker. It's one of those unfortunate situations where the Martian atmosphere is not sufficiently thick that you can really use a parachute alone. Neither is it sufficiently thin that retro rockets alone would do the job. So it's this compromise where we have got the heat shield and being able to maneuver the spacecraft while it's flying through the atmosphere at these terrific speeds, then deploying the parachute, and then using the retro thrust system before we get close enough to the ground to use the sky crane. So it's a pretty challenging situation, whichever way you want to think about it. I guess my microphone mightn't have been in the right position just then. Sorry about that.
Yes, I can hear you much better now.
Yep, sorry. It's exciting though. And as I say, physics in action, engineering coming to the forefront here. This is not so much science at the moment. This is our engineering colleagues showing their stuff, their computer programmers strutting their stuff, and science will come to the fore after we get to the ground.
All right, thanks very much. That was very exciting. So we have fulfilled our first milestone a little bit ahead of time, I think. So if we go back here, our cruise stage separation, we're just a few minutes behind here, and we're looking at atmospheric reentry in now 4 minutes. So what I'm going to do is quickly hop over and we'll talk a little bit about some of these fascinating science that might be coming out. Now, let me just see if I can load this up. Gagan, I believe you have a quick little bit about water on Mars, especially as we've been talking about the Jezero crater being an interesting water site. Would you like to go ahead on this?
Yes, absolutely. Let me just get started here. Yeah, so I believe we've talked a little bit already today about the Hellas Basin, our basin, and a couple of other places with water on Mars, such as the poles, which are all really interesting sites. And one of the big things that Perseverance aims to do is determine if, determine the possibility of a manned mission, in the near to distant future. And one of the big things with any manned mission is a water supply. So finding a water supply is no small feat in outer space, of course, and a lot of the water that astronauts use on the International Space Station is actually reused and recycled water, and it runs through various purifying systems that make it safe to drink and use for human purposes again. So finding a reliable water source on Mars is also going to be a similar problem, because since missions will likely be a little longer, crews will likely want to have backup water sources just in case something happens to their main water source and they can't reuse it. So this is one of the important aspects of a mission that NASA has to, or any other space agency would have to plan out. So to us, water is considered one of the most important factors to consider when wondering whether other planets are habitable. The planets we consider most likely to harbor life in a form familiar to us are those that have evidence of water. And the debate about the presence or absence of water on Mars was a very long one indeed, which we can now say pretty confidently is over. The earliest evidence for water on Mars was collected almost completely by the Mariner 9 spacecraft, and it came in the form of erosion patterns imaged on the Martian surface that looked strikingly similar to patterns of erosion left by water on Earth. These included large canyons, outflow channels near valleys, or other formations that could have been ancient rivers or lakes. Other evidence for water on Mars included massive low-altitude areas that showed clues of historical lake-like bodies of water, such as the Hellas Basin and the Valles Marineris. The Hellas Basin, as we talked about earlier, is very interesting because it is so incredibly deep. Hellas is a massive impact crater on Mars with a diameter of 2,300 kilometers, and the bottom of the basin is over 9 kilometers lower in altitude than the rim of the basin. And I think I popped this fun fact in earlier. If you put Mount Everest in its entirety inside the basin, the peak would still be lower than the height of the rim by a lot. So since the crater is so deep, under certain atmospheric and temperature conditions, which can be comparable to certain places on Earth, liquid water may actually be able to exist at the surface. And there has been recently found evidence of glaciers existing in the basin in the past. A lot of this evidence has been backed up by newer research and observation of Mars. Both the Mars Reconnaissance Orbiter, or the MRO, and the Curiosity rover have relayed images of landforms that support the idea of Mars having had a great deal of liquid water at some point in its history. However, most of this evidence for water on Mars is actually evidence that water had existed in the past. Until recently, there was little indication of water existing in the present on the surface of Mars.
Wonderful. And actually, we're just going to give a quick little shout out, atmospheric entry now. So actually, we're having atmospheric entry. This is the atmospheric entry for the lander coming in. You can see they've actually highlighted Jezero crater though. And we have confirmation of entry into the atmosphere. So this means, of course, if a signal arrived and confirmed atmospheric entry it actually happened 11 minutes ago. So
look at the speed. Look at the speed. 5 kilometers a second we're traveling at the moment, and only 140 odd, well, actually below 100 kilometers are now above the surface. So this is where it really, really gets tough for the spacecraft.
I heard a rumor that if you find a way to go fast enough, you won't set off the speeding radar in those automatic machines. This might have been a Mythbusters episode, but if anybody was going to do it, this would have a chance. This is an incredible, incredible speeds. So we have 5.3, was it 5.3 per second, I think?
Yep, yes, kilometers per second, yep.
5.3 kilometers per second, and they are entering the atmosphere, so they're going to try to slow down. And they're trying to do a bit of braking here. Of course, they've got a bunch of different maneuvers that have to happen. Now that they're in contact with the atmosphere, they have to safely deploy parachutes and all kinds of things.
Whichever way you cut it, this is a phenomenal speed. It's been converted into heat on the heat shield. The vehicle is maneuvering in the atmosphere. One of the big pluses that modern day landers have got is that they can land in very small landing ellipses. Jezero crater is not very wide, and we want to hit the middle of Jezero crater. So we're talking about a landing ellipse that is barely 20 kilometers in size. You compare that back to literally dozens and sometimes hundreds of kilometers in size for some of the earliest missions to Mars. So this too is a good indication of great technology advancing.
Indeed, and it does help that we're sky craning our way down instead of bouncing.
You didn't like the airbag bouncy, huh?
I really did. I just thought it was just so fun. It reminds me of Aussie rules football. So
it's very true. People might be wondering why we've abandoned that technology, but the short answer is Curiosity and Perseverance are too massive. They're over 1,000 kilograms, whereas the smaller rovers, Spirit and Opportunity, they were barely 250 kilograms. So you could use the airbag deploy technique. Not so for Curiosity and Perseverance.
Indeed, it would be very hard to build a bouncy ball big enough to contain this small car-sized package. This is actually the heaviest that is coming down now. So the heaviest load that has landed on Mars, or anywhere for that matter, I think.
That's right. Below 16 kilometers, so the surface is rushing towards us. The ground acquisition radar will be coming online very soon, and it only has literally 1 to 2 minutes to sort out exactly where it needs to go. So this is a big challenge as well.
Yeah, and we're watching this live here. I'll just put this on. So this might be a great time for anybody who of our crew who wants to make any kind of fingers crossed, or if there's a good luck thing you like to do, this is the time to do it. We have good telemetry, so you can see from their maps we are lined up correctly. This is new technology they're using with the ground finding, and it is obviously been heavily tested, but not on Mars yet. Oh, parachute.
Parachute deploy.
Oh, that's parachute deployment. Julie, do you have any wise words you'd like to impart here?
Wise? I don't know. It's still going like
kilometer a second.
It's just below Mach 1. It's kind of crazy.
Let me just align this here real quick and remove that one. Okay, here we go.
The last moments, this is really where you want things to work. It's done a great job coming through the atmosphere so far. It's washed off the vast majority of its energy, but it still has to come to zero in a controlled fashion.
Yes, starting off hypersonic, 5 times the speed of sound, and this final landing maneuver, the parachute that they've deployed, I'll just give a call out. This is 21.5 meters in diameter parachute, the largest ever used on Mars, likely due to the heaviness of this package, it deployed it faster than the speed of sound successfully. So deploying the parachute at just the right time is one of several steps critical for this accurate landing. And where are we now?
Radar lock has occurred, so it's found the ground. It's comparing with its onboard maps.
We have found the ground, and it wasn't.
This is important.
Many things could go wrong. Many things have gone right. So we're fingers and toes crossed.
It's identified its landing terrain. It knows where it needs to go. This is good.
Absolutely. This radar lock, this new terrain relative navigation, I believe this is the first time this has ever been used on another planet. It seems to be working.
Quite correct.
Hopefully it will, be followed by a sky crane. Oh, confirmation, the back shell has separated. Back shell has separated. Very exciting.
These guys are looking very calm at mission control. They're probably calmer than we are, but still.
I don't know. I feel like you could cut the tension like a knife, like with a knife.
Fair enough. Yeah. Tell you what, this is, the hopes and dreams of hundreds of scientists and engineers who have worked, most of their careers on this moment.
Yes, and it is something we're all hoping for here. Hundreds of things have to go right, but they are, getting closer and closer every minute here, or every second, I should say. And all of this happened 11 minutes ago.
That's exactly right. The speed of light, it's really annoying, 300,000 kilometers a second. It still takes, about 8-9 minutes to get to Earth. So, yeah, it happens.
To be fair, the speed of light is usually okay.
Well, yes, usually. but when you want to know, this is all over bar the shouting, and we still don't know the answer.
Everybody who wants to turn on your cameras and say yay. Hooray!
Woo-hoo.
Woo!
So now we sit back and wait for that beautiful image that they will quickly snap and say, "Hi, I'm here." Wonderful effort. It went like clockwork as far as I could tell.
Yeah, the sky crane followed by the flyway of the descent vehicle seems to have gone perfectly. I didn't see any problems with the flyway. It happened very, very quickly. And that's the last 12 seconds. We, sort of zooming in a bit, they had the sky crane lowering it, and the descent vehicle has to then, of course, fly away from the rover so that it doesn't crash into it. And it seems to have happened. So it is there, it was there 11 minutes ago. So now what we want to know is, how there is it? Can we get signals back? Everybody jump up and down.
Hey, the fact that it has gotten down has increased the likelihood of terrific telemetry transmission immeasurably. It did, I say, picture perfect. The engineering timeline seemed to flow almost to the second. The tones, the sequencing, a real triumph of engineering, and not to mention computer programming. All this being done on autopilot with us all chewing our fingernails here to bits. It's just a phenomenal effort by NASA yet again.
I have to say that 7 minutes was like 35 seconds long.
Some of our colleagues at Mission Control will probably suggest to you it was about 3 years. But anyway, I understand. Time does strange things.
Once the adrenaline hits, it's all relative.
Exactly. But we've grown accustomed to these sorts of successes. Let us not forget that going to Mars is hard. Several of the students have commented on the variety of missions that have taken place, not just to Mars, but throughout the solar system, but in particular Mars. Putting aside the great disasters of the space shuttle era, getting to Mars, getting it onto the ground really is a hard thing to do. And the fact that NASA makes it look so easy is just terrific compliments to them.
First image coming through, they said they've successfully got a signal coming out. Sorry to interrupt you.
Excellent.
It's okay. I'm happy for that.
Yeah. Landing's just the first step, right? There have been missions that successfully landed that didn't manage to communicate back.
Is that it on the right?
There is an image on the right, but it looks like Jezero crater from altitude.
It does, but it might have been they were flashing, they were taking images all the way down, so that might be one of the first images.
And sound recordings. So well, hopefully those sound recordings become available soon as well.
I have no doubt that NASA will be releasing these things as there it is. There it is.
It's Mars. We made it, everyone.
That's
surface image. It's there.
That's from one of the navigation cameras that's near the wheel. So that's what they'll be using to drive. So it's a quick and dirty image, literally, but nonetheless, feet on the ground or wheels on the ground, I guess, is really the answer on this occasion. Wow. They are there in Jezero crater. Excellent. Just excellent.
So I don't see any fish fossils yet, but I've got my fingers crossed.
No kangaroos, no beavers, no nothing in that regard. No surprise, but nonetheless.
That's what they're looking for, of course, is this microbial life. And that we'll have to wait for the advanced instruments to turn on.
Yes. Yeah, it's a terrific mission that they've got planned. This is a huge, huge hurdle to have passed, but the next several years are going to be absolutely phenomenal. The instrumentation, like Curiosities, turns up interesting answers and asks more questions as they move around the surface. But yeah, this is great stuff today. But yeah, the more exciting stuff in terms of science is yet to come. Oh, they've got another one.
This is where the fun begins.
Oh, wow.
That's exactly right. The fun does begin for all of those scientists who are eagerly awaiting the data that will come from the surface to begin their analysis of the environment at Jezero crater. And it is an exciting environment. I mean, a lake bed, the river delta, you know, they're planning to start from the middle, work the way towards the more interesting science areas, and then up onto the crater rim and out of the crater if all goes well. I mean, it really is an ambitious mission, but you know, it's now underway. It really is.
Does that rock look like a potato to anybody? It's that one rock. There was one rock in there. Yeah, that one. It really, really looks like a potato.
Well, okay, we'll go with that. Sure. Not a problem. Not a problem. Actually,
I mean, they started naming rocks with Pathfinder and Sojourner, so why not?
That's right. Actually, that image reminded me just a little bit of Titan. The image that was sent back by the Huygens probe had a couple of sort of smallish rocks. They were primarily ice right in front of the camera. That navigation image really did remind me of Titan just for a moment. Very different environments, though. Very different indeed.
I can only hope it's because there's some sort of residual softening in the basin due to that, of course, clays and salts and water.
Correct. That's right. They've detected clays in this area from aerial surveillance.
Well, that's the last regular image from NASA going through. Of course, we have about, lots and lots and lots of things we could still talk about for Mars. We won't be able to stay on for too long today.
No.
But it has been an amazing show, and we will be using all of our material we didn't get to in a future TeleTube episode. So I am going to go ahead and say NASA's broadcast has finished for now. Those first images have come out. So congratulations to everybody, and thank you all very, very much for joining us on this exciting Mars adventure. We have had an absolute blast of a time, I would say, but maybe not blast, a very soft and safe landing of a time. Is there a phrase for that we could use?
Don't know, lost for words, but yes.
Yes.
Congratulations to all of the students who gave terrific presentations today, giving a very good summation of not just Mars exploration, but spacecraft exploration over the last 60 plus years. So really set the scene for the excitement of Perseverance's landing.
Absolutely, and it has been an amazing, amazing event. I am so happy that they're there and we got to see those initial images. So I'm just going to go ahead and wrap up, I think, for our broadcast now. And of course, looking forward to what NASA releases next. Hopefully some rover moving around sounds. And we'll go ahead and probably wrap up our broadcast for today, and looking forward to more fun Mars events coming soon. So let me just get this started here. And of course, a big thank you to all of our crew who have worked so hard on this episode and creating the material for it. We'll go ahead and say thank you, everybody. We're going to go ahead and wrap up now, and you all have been listening to the Alan I. Carswell Observatory's special Mars Perseverance 2021 TeleTube broadcast. This broadcast, as well as our regular Wednesday night broadcasts, are presented by the students, faculty, alumni, and friends of York University. This show in particular was put together by our York Observatory 2020 Mars crew members, Amin, Gagan, June, Noah, Shannon, Obada, and Matt. And Obada in particular wasn't able to join us today, but contributed a lot to several of the slides. So thank you everybody for joining us, and thank you Julie and Paul and Jesse for hopping in and commenting and sharing in the excitement. Make sure to leave any comments or questions in the comment section of the video. You can always connect with us on Twitter or Instagram with the handle of @York Observatory, and on Facebook at Alan I. Carswell Obs. All of our programs are free, but if you'd like to make a donation, see our website at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night, everyone.